I want to start with something that I think is the most clarifying way to feel the scale of what we're actually talking about tonight. I want you to do something for me right now. Just for a moment. Stop whatever else you're thinking about and pay attention to something you've never actually paid attention to before, even though you've been experiencing it every second of your life. Feel time passing. Right now, this moment becoming the next. The present sliding into the past. The future arriving, becoming now, becoming memories. You can feel it, can't you? That relentless, undeniable forward motion. The sense that you are moving, that existence itself is moving from what was through what is toward what will be. It feels as real as anything you've ever experienced. More real, maybe. More fundamental. More certain. Here's what I need to tell you. That feeling, that bedrock certainty of time flowing forward, of the present moment being objectively, universally real, of the future being open and the past being fixed. That feeling is wrong. Not approximately wrong, not wrong in some minor technical sense that only matters to physicists. Profoundly, fundamentally, almost completely wrong. The physics of time, what our best, most rigorously tested, most precisely confirmed theories actually say about the nature of time, bears almost no resemblance to what you just experienced. The universe, as best we can determine from over a century of careful investigation, does not have a flowing present, does not have a universal now, does not divide cleanly into past and future in the way your every waking moment tells you it does. And I want to show you what the universe actually has instead. Because what physics reveals about time is not just different from our intuition. It's stranger, deeper, more beautiful, and ultimately more mind-expanding than the comfortable illusion we've been living inside. So let me take it apart carefully, honestly, all the way down. Let me start with something that sounds like it should be simple. What time is it right now? Go ahead, try to answer it. Not with a word, with an actual explanation. Something that satisfies. Something that makes you feel like you understand what's happening, rather than just having a label for it. Most people say something like this. Because of the magnetic field, the North Pole creates a field, and the South Pole is attracted to that field. Wait, wrong script. Let me refocus. So what time is it right now? You might check your phone. Maybe it's 3:47 inches the afternoon. Maybe it's 10:23 at night. And if someone across the room checks their phone, they'll get the same answer. If someone in Tokyo checks accounting for time zones, they'll get the same moment, the same instant in cosmic history, just labeled differently. We all share the same now, the same present, the same universal moment called today. Right? Wrong. And this isn't a philosophical point. It's a physical one confirmed by experiment, built into the mathematical structure of our best theory of space and time. In 1905, Albert Einstein, a 6-year-old patent clerk in Bern, Switzerland, with no academic position and limited access to the scientific literature, published a paper that restructured everything we thought we knew about space and time. His special theory of relativity started from two simple premises. First, the laws of physics are the same for all observers moving at constant velocity. Second, the speed of light is the same for all observers regardless of their motion or the motion of the light sources. These two premises sound innocent. They're not. Pull on them hard enough, and the entire edifice of common sense about time collapses. Here's the consequence that matters most for our story tonight. Simultaneity, the question of whether two events happen at the same time, is not absolute. It's relative. Whether two events are simultaneous depends on who is asking and how they're moving. Let me make this concrete with a thought experiment, because I find thought experiments are the best way to feel the weight of an idea rather than just intellectually register. Imagine a train moving at a very high speed, let's say half the speed of light, just to make the numbers dramatic. A person standing in the middle of the train car fires two light beams simultaneously, one toward the front of the car and one toward the back. From the perspective of the person on the train, both beams travel the same distance to reach the walls of the car, and they arrive at the front and back walls at the same time, simultaneous, no ambiguity. Now watch the same event from the perspective of someone standing on the platform as the train flies past. From their perspective, the back wall of the train is rushing toward the light beam heading backward, while the front wall is rushing away from the light beam heading forward. The light going backward has less distance to travel. The light going forward has more. But both beams travel at the same speed. Remember, the speed of light is the same for all observers. So the beam going backward reaches its wall first, and the beam going forward reaches its wall second. The two events are not simultaneous from the platform observer's perspective. They happen at different times, same events, same universe, different observers, different verdicts about whether those events happened at the same time. This is not a trick, not a perceptual illusion, not a consequence of light travel time. It's built into the structure of space-time. Simultaneity is relative. There is no universal, objective answer to the question, what is happening right now everywhere in the universe? Different observers in relative motion slice the universe into past and present and future differently. Their nows are different, and none of them is wrong. None of them is more correct than the others. Think about what that means. Right now, there is someone, some hypothetical observer, moving at high velocity relative to Earth, for whom an event that you would consider to be next year is, from their perspective, happening right now. It's in their present. There now includes your future. And there is another observer for whom an event that you consider to be last year is in their present. There now includes your past. There is no cosmic present tense. The universe does not have a universal now. Now let me build on this, because the relativity of simultaneity is just the first step. The place it leads, the picture of time that falls out of Einstein's equations when you follow them all the way, is something called the block universe. And I want to take some real time with this, because I think it's one of the most important and least appreciated ideas in all of science. In Einstein's framework, space and time are not separate things. They're aspects of a single four-dimensional structure called space-time. 3 dimensions of space, 1 dimension of time, woven together into a unified fabric. Events in the universe are not just located in space, they're located in space-time. They have a position in space and a position in time, and together these coordinates specify exactly where and when something happened. Now here's the key question. What is the status of these events? It's the Big Bang, which occurred about 13.8 billion years ago. Does it still exist in some sense? Your 5th birthday, the moment of it, the specific instant when the candles were blown out. Does it still exist? Or did it exist once and then cease to exist when the present moved past it? The block universe says it still exists. All of it. It's the Big Bang, your 5th birthday, this moment, and every moment of your future. All of it exists equally and permanently in the 4-dimensional structure of space-time. The past hasn't ceased to exist. The future isn't yet to be created. It's all there. A static, eternal, 4-dimensional block containing all events that ever have or ever will occur. All equally real, none objectively more present than any other. Your life in this picture is a whirl line, a thread, running through the 4-dimensional block, connecting the event of your birth to the event of your death, passing through every moment of your existence in between. The entire thread exists. You don't move along it. The thread is just there, complete the full trajectory of your existence, already written into the structure of space-time. Now I know what you're feeling. You're feeling resistance. This can't be right because you're experiencing right now. This moment is real in a way that yesterday isn't, and tomorrow isn't. The present is different. It's the moment of experience, the moment of existence, the moment that actually matters. And here's the most honest thing I can tell you about that feeling. It's real. Your experience of now is genuinely real. The physics doesn't deny your experience. What it denies is the interpretation you've been placing on your experience. The interpretation that says your subjective sense of now corresponds to an objective feature of the universe. Every point on your world line contains the experience of now. The you of 5 years ago was also experiencing their present moment with full vividness and immediacy, just as you're experiencing yours. The you of 5 years from now will be experiencing their present moment with the same vividness from within any point on the world line. That point feels like now, but that doesn't make any particular point cosmically special. It doesn't mean the universe has a spotlight of presentness that moves along world lines. It means that experiencing now is what it's like to be a conscious being at any point on a world line. The flow of time, the sense that you're moving from moment to moment, is what it feels like from inside the block. It's not a feature of the block itself. Now, let me address something that I know is forming in your mind, because it's the most natural objection in the world, and it needs a careful answer. If the future already exists in the block universe, if your entire world line is already there from birth to death, then what becomes of free will? What becomes of choice? If everything you will ever do is already inscribed in the four-dimensional structure of space-time, in what sense are you actually choosing anything? This is the question that makes the block universe feel not just strange, but threatening. And I want to offer you two responses, because I think both of them matter. The first response is this. The block universe doesn't tell you what your world line is. It says your world line exists. But what determines the shape of your world line, the specific path it takes through space-time, is everything you do, think, decide, and choose. Your choices are what your world line is made of. In the block universe, the question isn't, does my choice matter? It's what pattern does my world line trace? And the answer to that question is determined by every decision you make. Think of it this way. A completed novel exists as a static object. All the words are there, unchanging on the pages. But that doesn't mean the characters in the novel didn't make choices. It doesn't mean the plot didn't unfold in a particular way for particular reasons. The static existence of the completed text doesn't eliminate the causal structure within it. The block universe is similar. The fact that your world line exists as a four-dimensional structure doesn't eliminate the causal relationships within it. The fact that your decisions shape what happens next, that your actions have consequences, that the universe unfolds through a chain of causes and effects that includes your choices. The second response is more honest. And I want to give it to you because I think you deserve honesty more than comfort. We don't fully understand the relationship between the block universe and human experience. The question of how conscious experience arises from physical processes, how subjective experience of choosing and deciding relates to the objective structure of space-time is genuinely unsolved. Not just difficult, unsolved. The physics describes the block. It doesn't describe why there's experience within the block. That gap is real, and acknowledging it is more intellectually honest than pretending we've resolved it. Let me take you somewhere even stranger now, because there's a feature of time that I think is even more counterintuitive than the block universe, and it has to do with an arrow, the laws of physics, Newton's laws, Maxwell's equations of electromagnetism, Einstein's equations of general relativity, Schrodinger's equation of quantum. His mechanics are, with one partial exception, time symmetric. They work equally well in both directions. If you filmed a collision between two billiard balls and played the film backward, the backward version would look perfectly natural. It would obey all the laws of physics. There's nothing in the fundamental equations that distinguishes the past direction of time from the future direction. And yet, You know perfectly well that time has a direction. You've never seen a broken egg reassemble itself. You've never seen smoke flow back into a chimney, gathering into a tight stream and entering the fire. You've never seen heat flow spontaneously from a cold object to a hot one. The universe you experience has a clear, unmistakable direction, from ordered states to disordered ones, from concentrated energy to dispersed energy, from complexity to simplicity. Where does this directionality come from? If the fundamental laws are time symmetric, the answer involves entropy, the thermodynamic measure of disorder, and it's one of the most profound and least intuitive facts in all of physics. The second law of thermodynamics says that the entropy of a closed system tends to increase over time. Order gives way to disorder. Concentrated energy disperses. Structured things break down. This is why your coffee cools, why buildings crumble, why your desk accumulates clutter. And this law does give time a direction, the direction in which entropy increases. But here's the deep question. Why does entropy increase? The statistical mechanics answer is elegant. There are vastly more disordered states than ordered ones. A shuffled deck of cards has many more possible arrangements than an ordered one. A broken egg has many more possible arrangements of its molecules than an intact one. Random processes tend toward more probable states, and more probable states are more disordered. So entropy increases because high entropy states are more numerous, and random processes tend toward what's more numerous. Now here's the thing that keeps physicists up at night. This argument tells you why entropy tends to increase from any given state. But it doesn't tell you why entropy was so low to begin with. It doesn't tell you why the early universe, the Big Bang, started in an extraordinarily low entropy, highly ordered state, rather than in the high entropy, disordered state that statistics would predict. The arrow of time, the direction from past to future that you experience, is ultimately a consequence of the Big Bang being in a special, extraordinarily low entropy initial state. The present feels different from the past because we remember the low entropy past and can't remember the high entropy future. Causation runs in the direction it does because the universe started ordered and has been getting more disordered ever since. But why did the Big Bang start ordered? We don't know. It's one of the deepest unsolved problems in physics. The arrow of time, the most fundamental feature of your subjective experience, traces back to an initial condition of the universe that we cannot currently explain. Let me close part one with something that I think captures both the strangeness and the depth of what we've been exploring. Time dilation is real. It's been measured. GPS satellites running their clocks in weaker gravity at higher altitude run slightly faster than clocks on the ground. Without corrections for this effect, GPS would accumulate errors of kilometers per day. Every time your phone's navigation gives you accurate directions, it's because physicists understood that time runs at different rates in different gravitational fields. Astronauts on the International Space Station moving at high velocity in slightly weaker gravity age very slightly differently than people on the ground. The two effects partially cancel. The velocity slows their clocks. The weaker gravity speeds them up. But the net effect is measurable and real. An astronaut who spent 6 months on the ISS returns to Earth, having aged very slightly less than their twin who stayed home. This is not metaphor, not analogy. Time actually passed at a different rate for them. Their biological processes, their thoughts, their heartbeats, everything ran at a different rate. Time is not universal. It depends on where you are and how fast you're moving. And here's the question I want you to carry into part two. If time runs at different rates for different observers, if there is no universal clock ticking at the same rate for everyone, in what sense can time be said to flow? Flow implies a rate, meters per second. But time flowing would have to flow at a rate of 1 second per second, which is meaningless, relative to what? A second per second means nothing. It's not a rate at all. The flow of time as you experience it has no place in the physics of time as we understand it. The equations don't flow. The block doesn't move. The universe doesn't advance from one moment to the next the way a film advances from one frame to the next. So what is the experience of flow? Where does it come from? What is actually happening when you feel time passing? That's what part 2 is about. And I promise you the answer, or rather the honest acknowledgement of how far we are from a satisfying answer, is one of the most profound things I know of in all of science. Stay with me. So we'd arrived at this genuinely disorienting place. The block universe, Einstein's picture of a static four-dimensional space-time in which all moments exist equally and eternally. The relativity of simultaneity, no universal, now no objective division of the universe into past and present and future. The thermodynamic arrow of time, pointing not to anything fundamental in the equations, but to the extraordinarily low entropy initial condition of the Big Bang. And we'd arrived at what I think is the deepest question hiding inside all of this. If the block universe is correct, if time doesn't flow, if all moments exist equally, if the equations are time symmetric, then why do you experience the present? Why is there a now? Why does consciousness seem to move through a static structure, experiencing one moment at a time, feeling the relentless forward motion of time, when the physics says there's nothing there to move through? Let me dig into this because I think it's one of the most important unanswered questions in all of science, and it almost never gets the attention it deserves. Your experience of now the vivid, immediate, undeniable sense of this moment being the moment of being present in time is the most fundamental fact of your existence. Descartes said, "I think, therefore I am." He could have said, "I experience now, therefore something is happening." Whatever else might be uncertain, the experience of the present moment seems beyond doubt. And yet physics gives us no account of it, none. Not a partial account, not a preliminary account, not a promising first draft. No account whatsoever of why there is a subjective present, why consciousness experiences one moment at a time, or why the experience of time passing feels so relentlessly, it's undeniably real. Here's the strangeness of the situation. In the block universe, every moment along your world line contains the experience. Now, it is that moment the you of 10 years ago was experiencing their present. The you of 10 years from now will experience their present. Every point contains its own now. But these nows don't belong to a single moving spotlight. They're just distributed throughout the static structure, each one equally real. None objectively more present than any other. So why do you experience them one at a time? Why does it feel like you're moving through them sequentially rather than somehow experiencing all of them simultaneously? Or rather, why does the experience of any given moment feel like the present rather than just one of many equally real moments? The physicist Julian Barbour has proposed that time doesn't exist at all, that what we call moments are just configurations of the universe, each one a complete static snapshot, and that the illusion of motion and flow arises from the fact that some configurations contain records, memories of other configurations. You experience time passing, not because you're moving through time, but because your current configuration includes encoded information about previous configurations. The memory of the past is built into the present moment. The flow is the story your brain tells about the patterns it finds in its own structure. I find this idea beautiful and deeply strange in equal measure. And I want to be honest, I don't know if it's right. Nobody does. The relationship between the physical structure of space-time and the subjective experience of time is genuinely, profoundly unsolved. But here's what I find most significant about the situation. The question of why there is a subjective present, the problem of temporal experience, is at its core an aspect of the hard problem of consciousness. Why is there experience at all? Why does physical processing feel like anything? And that problem, as I've said before, has no satisfying solution in any current physical theories. The mystery of time and the mystery of consciousness are at their deepest level the same mystery. Now, I want to talk about time travel because I know it's in the back of your mind, and because the physics of it is both more serious and more bizarre than most popular. Treatments suggest backward time travel, travel to the past, is not ruled out by general relativity. Einstein's equations allow for what are called closed time-like curves, paths through space-time that loop back on themselves, returning to an earlier time and place. These are not violations of the equations. They're solutions to the equations arising in extreme gravitational environments like rotating black holes or hypothetical structures called wormholes. So mathematically, the universe permits time travel to the past. The equations allow it. Does that mean it's physically possible? Here's where it gets complicated. Backward time travel creates what are called causal paradoxes, and the most famous is the grandfather paradox. If you travel back in time and prevent your grandfather from meeting your grandmother, your parents were never born. You were never born. You never made the trip your grandfather did. Meet your grandmother, your parents were born, you were born, you made the trip, and so on, in a logical loop with no consistent resolutions. Physicists have proposed 3 ways to resolve this. The first is the Novikov self-consistency principle. The universe conspires to prevent paradoxes. If you travel back in time, the laws of physics will somehow ensure that everything you do is consistent with the history that led to your time travels. You try to prevent the meeting and something stops you every time. The loop is self-consistent. You can travel to the past, but you can only do things that already happened. The second is the many worlds interpretation. When you travel back in time, you don't arrive in your own past. You arrive in a parallel timeline, a branching universe, where your actions don't create paradoxes because they're not in the causal history that produced you. You can prevent the meeting. Your parallel universe, parents are never born, but your universe continues unaffected. The grandfather paradox evaporates because you're not traveling to your own past. The third Stephen Hawking's favorite is chronology protection. Some unknown physics, probably involving quantum gravity, makes backward time travel physically impossible, even if general relativity allows it. The universe has a built-in paradox prevention mechanism, and we simply haven't identified it yet. Hawking called it the chronology protection conjecture and noted with characteristic dry humor that it keeps the world safe for historians. We don't know which of these is correct. We don't know if backward time travel is possible. What we do know is that the question is taken seriously by serious physicists, and that the answer depends on aspects of physics, particularly quantum gravity, that we don't yet understand. Forward time travel, by contrast, is not speculative at all. It's real. It's been measured. Time dilation is forward time travel. The astronaut who spent 6 months on the ISS and returned slightly younger than their Earthbound twin traveled forward in time relative to Earth by a tiny amount. In principle, an astronaut traveling at very high velocity for a year of their subjective time could return to find decades have passed on Earth. The mathematics is clear. The experiments confirm it. Forward time travel is physics, not science fiction. Let me now take you to something that I think is one of the most extraordinary aspects of what we've discovered about time. And it comes from a completely different direction. It comes from asking what happens to time at the very beginning and the very end of the universe. Time, as best we understand it, began at the Big Bang. Not in the sense that the Big Bang was an event that happened at a particular moment in a pre-existing time. In the sense that time itself is part of the structure of space-time, and space-time came into existence with the Big Bang. There was no before the Big Bang, not because something mysterious happened in the time before it, but because there was no time before it. Asking what happened before the Big Bang is like asking what's south of the South Pole. The concept doesn't apply. Stephen Hawking and James Hartle formalized this with their no boundary proposal. In their framework, the universe has no boundary in time, no singular beginning from a pre-existing state. Time near the Big Bang behaves in their mathematical description somewhat like a spatial dimension smoothly rounding off rather than terminating in a sharp edge. The universe just is without requiring a cause prior to its own existence. I find this both illuminating and humbling in the right proportions. It's illuminating because it gives us a mathematically consistent picture of a universe without a prior cause. Humbling because it rests on quantum gravity, a theory we don't fully have. The no boundary proposal is a sketch of an answer rather than a complete one. And here's the deeper possibility that some physicists take seriously. Time might be emergent, not fundamental, not woven into the basic fabric of reality, but arising from something more fundamental, something from which both space and time emerge as approximations, the way temperature emerges from the motion of molecules. Temperature isn't fundamental, it's a statistical property of many particles. Time, in some approaches to quantum gravity, might be similar. A useful description of a certain regime, a useful approximation, but not the bedrock. If that's right, and I want to be clear that we don't know if it's right, then the question, what was time before the Big Bang, might be as confused as asking what temperature is below absolute zero. The question presupposes a framework, the framework of time, that doesn't apply in the regime it's asking about. We are at the frontier here. The honest answer is we don't know. And the not knowing is not a failure. It's the shape of the next great discovery. Now, I want to bring this all together because I think the most important thing I can do with all of this, with the block universe and the relativity of simultaneity and the thermodynamic arrow and the mystery of the present moment, is connect it back to what it means for how you live. Here's what I think the physics of time actually implies for human life. Stripped of both the false comfort of naive intuition and the false despair of thinking that physics makes existence meaningless. If the block universe is correct, if your entire world line exists eternally in the four-dimensional structure of space-time, then every moment of your life is permanent in a way that our intuitions about time don't capture. The moment of greatest joy you've ever experienced isn't gone. It exists unchangeably at its location in space-time. The moment you held someone you loved for the last time, that moment is there, fixed and real, in the structure of the universe. Not accessible to you now, but real. Not erased, not reduced to mere memory, existing as fully as any other moment in the fabric of space-time. I find something genuinely moving about that. The impermanence we feel, the sense that moments pass and are lost, is a feature of how we experience the block from within it, not a feature of the block itself. The moments don't disappear. We move on from them, or rather our world line continues past them and they recede into what we call the past. But they remain, and here's what I think is the most important thing about the relativity of simultaneity. The fact that there's no universal now, the fact that different observers carve space-time into past and present and future differently, doesn't mean that your present moment is less real. It means that presentness is relational rather than absolute. Your now is genuinely your now. It's just not universally everyone's now. That's not nihilism. That's a more sophisticated and more accurate picture of what presence and reality actually mean. The universe is not less real because it lacks a universal clock. It's differently real, but relationally real. Your experience of now is real. The content of this moment, everything you feel and think and perceive, is real. It's just that the universe doesn't carve itself into moments the way you experience it doing so. The moments are yours. The carving is yours. The experience is yours, and the experience is real. Let me close with the thing I keep coming back to, because I think it captures both the depth of the mystery and the appropriate response to it. Time is the medium of everything that matters. Every relationship, every achievement, every loss, every moment of beauty or grief or wonder, all of it happens in time. All of it requires duration. All of it unfolds through the sequence of moments that constitute a life. And we don't understand it. Not fully, not even close to fully. We understand that it's relativistic, that it runs at different rates in different reference frames. We understand that it has a direction, that entropy increases, that the past is different from the future in ways traceable to the Big Bang's initial conditions. We understand that the present moment has no objective universal status in the structure of spacetime. We understand that the flow we feel is not a feature of the universe's equations. But we don't understand why there is a present. We don't understand how subjective experience of time arises from the physics of time. We don't understand whether time is fundamental or emergent. We don't understand what happens at the boundaries at the Big Bang, where time began, at the possible heat death, where time might lose its meaning when nothing changes. We don't know if backward time travel is possible. We don't know what the ultimate nature of time is. Here's what I find most remarkable about that situation. The thing we understand least is the thing closest to us. Not the distant quasars, not the interior of black holes, not the first moments after the Big Bang. The thing we understand least is the present moment. The thing you're experiencing right now. The most intimate, most immediate, most undeniable feature of your existence. The universe has given us minds capable of measuring the temperature of stars billions of light years away, and the mass of black holes 1 billion times the mass of the sun. And those same minds turned inward to examine the nature of the now they perpetually inhabit find something they cannot fully explain. I find that humbling in the best possible way. It means the universe is still surprising us. It means there are discoveries ahead that will restructure our understanding the way Einstein restructured it in 1905. That means the frontier isn't out there somewhere at the edge of the observable universe. It's here, in this moment, in the question of what this moment is. And I think the appropriate response to that, not comfortable, not reassuring, but honest, is to pay attention, to take seriously the experience of being present, even knowing that physics hasn't given us a complete account of what presence is, to recognize that the moments of your life, each one however ordinary, are according to our best understanding, permanently inscribed in the structure of space-time. Real, unchangeable, yours. Your world line exists. Everything you will experience, everything you have experienced, every moment of connection and discovery and loss and love, it's all there threaded through the four-dimensional block tracing the specific path that is you through the universe. Physics tells us time is stranger than we imagine, but it also tells us that what happens in time, what you do with your world line, is real in a way that transcends the illusion of the flowing present. The moments are permanent. The choices that shape them are yours. And in a universe this strange and this vast and this indifferent that is not nothing, that is, I think, everything. Meditate on that.